Oh yes, you are most welcome once again to my YouTube channel. This is still your tutor Peter Ekaja, and I am here to take you through the continuation of type 2 partial fractions, where we are particularly going to be talking about a denominator with a quadratic factor. Now, these are just more examples in addition to our previous tutorial that you expected to have followed by now, in case you have not done so. Now, as you can see in our question, they're telling us to express 6 minus x divided by 1 minus x into brackets 4 plus x squared into partial fractions, and then they also expect us to find the integral of the same expression. We shall begin by still letting 6 minus x divided by 1 minus x into brackets 4 plus x squared to be equal to a divided by 1 minus x, because this is a linear factor first, and then for the quadratic factor we shall say bx plus c divided by our quadratic factor, which is 4 plus x squared. Again, the LCM of the right hand side is as good as the denominator of the left hand side, and therefore they cancel out, implying that we shall have 6 minus x equals to a into brackets 4 plus x squared, and then plus bx plus c into brackets 1 minus x. Now we can begin using the cover-up method to some extent by looking at particularly this factor here. We can say when we equate that factor to 0, the value of x becomes 1. So it means I can say putting the value of x as 1, what we expect? We expect that on the left-hand side, it will be 6 minus 1, which gives us 5. And therefore, on the right-hand side, the whole of the second term becomes 0. But then the first term becomes 4 plus 1 squared, which is 5 times a, giving us 5a. And therefore, this means the value of a becomes 1. So our value of a becomes 1. We go on, and now we can put the value of x as 0. The intention here is to make sure we cover up the b, because we have bx here. And then on the left hand side, definitely we shall have 6 is equals to, on the right hand side, when you put a 0 in the place of x, shall have 4a plus, now bx becomes 0, the whole of it, then plus c into brackets 1. So the whole thing becomes 4a plus c. Now when you do that, we need to remember that the value of a is already 1. So we substitute for a as 1. That means 4 times 1 is 4 plus c, and therefore the value of c becomes 6 minus 4, which is 2. So now that we have got c as 2, to get the value of b, we have two options. Either we substitute a value of our choice, or we can equate coefficients. But the easiest is definitely going to be equating coefficients, and I will prefer the term with the highest power. So now, in case I want to equate coefficients, I will just say equating coefficients of, I think the best would be x squared. On the left hand side, you realize we don't have x squared anywhere. That means the coefficient of x squared is 0. On the right hand side, you realize when you open this first bracket, the coefficient of x squared would be a. And then when you come to the second term, when you open the brackets, the coefficient of x squared. And in this case, you need to be so careful. It will be negative b. It will be negative b if you open those two brackets carefully. So we shall have a minus b. So you remember we have the value of A, so it means we have 0 is equals to 1 minus B, and therefore the value of B becomes 1. So far we have all our values, A, B, and C, and that means the next thing is to substitute. So we shall simply substitute, and we say therefore, our expression we started with was 6 minus x divided by 1 minus x into brackets 4 plus x squared is actually equals to A, but we know the value of A. A was 1 divided by the first factor, which is 1 minus x, and then plus bx. But remember, we have the value of b already as 1, so it will be x, and then plus c, but our value of c is 2, divided by our 4 plus x squared. So from here, we can clearly say we have already expressed that expression as a partial fraction, but then there is a hence part where we are supposed to integrate. Now, when you look at the hence part, we shall definitely say integral of 6 minus x divided by 1 minus x into brackets 4 plus x squared with respect to x is equals to integral of 1 out of 1 minus x with respect to x plus integral of x plus 2 divided by 4 plus x squared. Now, for the second integral, we shall simplify it a bit. So I will first maintain this first one the way it is. And then for the second one, we can write it as integral of x out of 4 plus x squared. I am just splitting. It will be x out of 4 plus x squared, then plus 2 out of 4 plus x squared. All this we are going to integrate, and the best way is to handle each of the terms individually. And when you look at the first expression, for us to integrate it, we use simply the change of variables. You can let the denominator to be u. If you let u to be 4 plus x squared, differentiate it and proceed normally according to change of variables, and you will come up with the right answer. And then the second one requires us to make the use of the turn substitution. So it's now a matter of realizing that we are supposed to integrate 1 out of 1 minus x dx plus integral of x out of 4 plus x squared with respect to x plus integral of 2 out of 4 plus x squared with respect to x. And I have explained how to integrate each of these. The first integral will give us a natural logarithm, but remember it must be a negative of it, simply because when you differentiate 1 minus x, you get negative 1. So you use the change of variables carefully, like it was demonstrated in the previous tutorials. You will get this answer. Plus, now when you come to this integral here, when you carefully let u to be 4 plus x squared, and you proceed as we did in change of variables, you will come up with the answer as a half natural log of 4 plus x squared. And then for the third integral, we're supposed to use tan substitution. And when you do it carefully, you will come up with tan inverse of x out of 2. And then plus our arbitrary constant of integration. So that is our integral of 6 minus x divided by 1 minus x into brackets 4 plus x squared. So let's look at the next example. Next example seems to be direct. It says we directly find the integral of this. So sometimes they don't tell you to first express an expression in terms of partial fractions, but it must be out of practice that you realize that before we integrate this expression, we have to express it as a partial fraction. And then realizing that this is already a proper fraction, so we can easily categorize it as one of the types. And one of the types clearly here is type 2. So we shall begin by letting, in our solution, let 2x squared plus 2x plus 3 divided by x plus 2 into brackets x squared plus 3 be equal to a out of the first factor, which is just a linear factor, and then plus bx plus c divided by x squared plus 3, which is our quadratic factor. So quickly, the LCM again of the right-hand side is the same as the denominator of the left-hand side. So they cancel out, and therefore, we shall say 2x squared plus 2x plus 3 is now equals to a into brackets x squared plus 3 plus bx plus c into brackets x plus 2. And then we begin by using the cover-up method. Equate x plus 2 to 0. The value of x becomes minus 2. So we shall say equating x, or putting x as negative 2. What happens when you substitute negative 2 on the left-hand side carefully? You will have 7. And on the right-hand side carefully, you will have 7a. That means the value of a becomes 1. So the value of a becomes 1. We do the same. Now we shall say putting x is equals to 0. When you put x equals to 0, on the left-hand side, you expect to come up with 3. And on the right-hand side, you expect to come up with 3a, 3a plus 2c. If you do it carefully, that's what you expect. But remember, you have the value of a. That means you shall have 3 equals to 3 plus 2c. When you do that, the value of c clearly comes to 0. If the value of c is 0, we can now move on and look for the value of b. So we can now equate. We can say equating coefficients, preferably coefficients of x squared. What shall we realize on the left-hand side? On the left-hand side, we shall realize we have a 2. On the right-hand side, it will be a plus b. That means now we know the value of a. So this will be 2 equals to 1 plus b, and therefore b becomes 1. So now that we have the values of a, b, and c, we can make a conclusion. Can first make a conclusion that therefore 2x squared plus 2x plus 3 divided by x plus 2 into brackets x squared plus 3 is actually equals to 1 out of x plus 2 plus x divided by x squared plus 3. There we are. And then when it comes to the integration, integral of 2x squared plus 2x plus 3 divided by x plus 2 into brackets x squared plus 3 with respect to x is actually equal to integral of 1 out of x plus 2 into, with respect to x plus another integral of x out of x squared plus 3 with respect to x. Now to integrate each of these, the first integral gives us a natural log of x plus 2, and you use the change of variables carefully. When you also use the change of variables in the second integral, it gives you a half natural logarithm of x squared plus 3 plus our constant of integration. So this is how easy it is to handle type 2. And I think with this, the next is now an exercise for you. And then we meet in the next tutorial for type 3. Okay, so this is our exercise. It's a simple exercise. Be sure that before you integrate each of these functions, you'll be required to first express those expressions into partial fractions. And they're all under type 2. So one thing we need to know is I have number 1 and 2. Number 2 will also require you to substitute limits, which I believe we now have the ideas if you've been following all my tutorials carefully. I wish you well, and I remind you to subscribe. I also remind you that we offer one-on-one online teaching to any learner across the world. In case you find need, you contact me on the contact that you should have seen at the start of this video so that we can help out each other. I wish you well. Subscribe and share with the rest of the world. See you in the next tutorial. Bye-bye.